Okay, year 10 students. This video is to help you to do the solve part of your assignment. Okay, what is the solve part of your assignment? Okay, so we know that in your assignment there are 5 parts of the contents. The first part is introduction, the second is observation assumption, which you have done, and the third part is mathematical model, which is what we call the solve part. Okay, so let's highlight this. Okay. Okay, so you can see this part is quite important because it accounts for most of the mark in your assignment. So it will take you most of the time to do it. Okay, and also if you can't if you don't know how to do solve parts, the mathematical modeling, that means it's very difficult for you to make sense of what are the observation assumptions in the second part, and you don't know what elements should be in that evaluation part. Okay, so that solve part is actually more important than the marks you suggest. Okay. Okay, so for the mathematical model part, we separate them into 5 smaller parts. Okay, so that's the sequence you need to do your work so that you could solve the problem that the assignment ask you to solve. Okay, so there are 5 parts. Okay, the first one is using tracker, the second one is Excel, the third is Desmos, and then you need to do algebraic work, and the last part is your decision on whether the ball will fall into the hoop. Okay, so I will try to do the first 4 parts with you, and the last part we might have some discussion in the class. Alright, and so let's see how could we present all the work you've done. Okay, obviously some of you have done some work in tracker and Excel and Desmos, but how could we present your work, and how can we do the algebraic work and to use your algebraic work to see what's the difference between the work using technology and without technology. Okay, let's have a look at the tracker first. Okay, so if you have a tracker, you know that we've done some you're tracking some the points that a flying basketball got on in the video. So you have a series of points, possibly 20 plus points you've got. Okay, so you need to save the screen for that tracker. So on that screen you need to show the axis. Okay, so you see 2 purple lines, you need to show the axis. Also you need to show number of points of the flying basketball, and also you need to show the position of the hoop. Alright, and another thing you need to show is that meter rule on the ground, which is used for the calibration. Okay, so for the tracker part, you need to write a few descriptions, and those descriptions should explain or describe the following questions. Okay, how to do calibration, how to choose the axis, okay, and how many points were taken for the flying basketball, number of decimal points for those coordinates, what are the coordinates of the hoop. Okay, so all these questions you should have a few description for the answers, right? And okay, so how about and next we transfer data to Excel. All right, so you need to copy and paste the data from the Excel into your reports. Okay, for the data, that should be two parts. One part is the basketball, the other part is the basket, or you might use the hoop. All right, so possibly I should be more consistent using the hoop. Okay, so there are many coordinates, and these coordinates are very important, not just for your work on Excel, but for your algebraic work as well. All right. So after you present the data in a table, then you need to present the graph, the scatter plots you've done in the Excel. Okay, and make sure on that graph it shows the equation as well, and also the R square value. Okay. Okay, again, you need to describe what you've done in the Excel. Okay, so it's kind of documentation you need to do. Okay, and there are some hints for you, and you need to try to answer them by through answering them. You give some description of the work you did in Excel. All right, so you need to tell. You need to state what kind of trend line is chosen to fit the scatter graph. Okay, so there are some options in Excel: polynomial, exponential, linear. Okay, so you need to answer that. I'm not going to give you the answer. Possibly you've already known the answer. What is the modeling equation from the Excel? Which is you have that on in your picture, but you still need to state that here. Okay. How fit is the model to the points? Okay, so how could you determine whether those the model you choose, how the model you choose fit the points? Okay, so you need to have certain values. You need to have certain explanation. All right, by using the values. Okay, certain values are given. Okay, so I don't want to give you all the answers. You need to work that out by yourself. How many decimal points are for the data points? Okay, right. Okay, then next it would be our Desmos. All right. So in the Desmos, you will do three different equations for the same group of data. Okay, so you need to watch our previous videos to know how to do this. Okay. Remember, we've done 3 videos before, so you could watch them so you have a good idea about how could we get all those equations in Desmos. Okay. So for Desmos, you need to think about what's the purpose to use Desmos. What the 2 or 3 equations generated from Desmos. You need to state the equations, how fit are they, alright? Okay, and the last part, possibly the most difficult part, is about algebraic work. First, we know that algebraic work at least involve two equations. Some of you might try to do 3 equations. That's okay, but I'm going to demonstrate 2 equations only, right? Okay. So first, let's see how could we do the vertex form. To do the vertex form, of course, you need to find the vertex from the group of data, and also need to find the y-intercept. If you don't like the y-intercept, you could have another point, but y-intercept is just more convenient for us, and vertex is a must. You must choose vertex. Alright, so how could we get the vertex from the data? Let's go back to the Excel, the data you've got from the Excel. Okay, so there are X and Y values for the flying basketball. So you need to find the the data of the greatest y. So which data give you the greatest y? It seems this one. Okay, so let's copy data. And okay, and also you need to get the y-intercept. Okay, so here's the y-intercept. Okay, so let's go back to here. So vertex is these two. All right, so possibly we'll just okay. So remember, this will be our vertex. Alright, so how about y-intercept? The y-intercept should be 0.00, 2.90. Okay, let's have a more consistent format over here. Okay, so we need to use the vertex and the y-intercept to find the vertex form. Okay, how could we do this? I'm going to demonstrate the process you need to present in your assignment. Right? Okay, let's go to here. Okay, so let's see. Now you've got vertex, which is 2.0. Okay, and y-intercept, which is 0. Okay, let's be more precise, 0.00, 1.70. Okay, so then you need to use the vertex template. So vertex template is a vertex form template is this. Okay, so we all know that B and C are the values of the vertex, right? So you could write A equals X minus B. So which value should be B? Should be 2.48 square plus 2.90. Okay. Then the next question is, how could we get this A? Alright, so you need to find this A. After you find A, you have solved the problem. You got the vertex form. Okay, but how can we do this? First, let's try to put that using try to use that y-intercept. Okay, so we know when x equal to 0, y will be 1.7, right? So you just put 1.7 here, and 0. Minus, sorry. Okay, so to solve this, you have this one, and of course you could use calculator, and then you minus 2.90 to the other side, and you will have minus 1.2, and you have that's one again, right? So A will be minus 1.2 divided by that. Alright, and that number is minus 0.95. Alright, but normally, since all the coordinates are only correct to 2 decimal places, so for the consideration of consistency, you might just use 2 decimal places. Okay, so A is just minus 0.20. Therefore, you have a vertex form okay, so that's a vertex form. But how do we know that this vertex form is actually correct? Okay, so let's go back to see that. Let's just pick any point. Okay, for example, you might want to pick this point. Right, 1.39. So x is 1.39. So let's see if y is 2.66. Okay, so let me. Okay, just remind me the value. Okay, so let's put tracking. Let's do some tracking. So let's see, x is 1.39. We need to check whether that's y is close enough to 2.66. Right, so okay, let's use calculator to track how large is this value. Okay, so you will have 2.66238. So when correct to 2 decimal place, 2.66, which are grades with the value in the table. Alright, okay, which are grades with the value in the table. Right, so that means the tracking agrees with the data in the table. Okay, so this vertex form is valid. So that's how you could get the vertex form. Alright, okay, next, after you got the vertex form, you need to work out another form, which is the general form. For the general form, you need to get 3 points. Alright, so let's get the first point, which is the general form. We don't need vertex, the y-intercept, sorry. So I make a mistake. Alright, so it should be 1.70. Okay, and then you need to pick up another 2 points. Okay, what are the 2 points? Okay, right, so let's go back to our previous table. Okay, so there are many points. Okay, you just get any 2 points, but you should avoid using the point we used before. Okay, you should avoid use vertex. Alright, because the vertex has been used to find the equation of the vertex form. We really want to use other points to find the general form. Okay, so what are the other forms? Right, so let's do this one. Okay, so this one is one of the points, let's say, and the other one, let me pick this point. So you see, I am not going to use the vertex form, but I could still use the y-intercept, because y-intercept is so useful. Alright, so I pick this point, which is 2.01 and 2.85. Right. Sorry. Okay, and another point, which is, let's say, 3.11 and 2.80. Alright, so you've got 3 points. Let's copy this and let's go to here. Okay, let's try to work this out using the general form this time. Okay, so to use the general form, first you need to use the general form template, of course. Alright, so remember the ABC here will be different to the ABC in the vertex form. That means different parameters. Okay, first, when x equal to 0, we know that y equal to 1.7. In this case, that just means you put 1.7 in the place of y. You got 0 here. Right, so basically you got c equal to 1.7. So that's why using y-intercept would be a very good strategy. Right, so let's do the other point. 2.85. Right, so what you need to do is to put this with this one. Right, and right now c is 1.7. Okay, so you want to simplify this a little bit. Okay, so in the end you will have 4.0401a plus 2b plus 1.7, and you need to move that 1.7 to the left hand side, and that number will become 1.15. Okay, so that would be one equation. Alright, so remember this equation. Okay, another equation. X equals, we use the other data set. X equals 3.11 and y will equals 2.80. Okay, so what happens to this one? Okay, for this one, we just have 2.80 a times 3.11 square plus b times 3.11 plus 1.7. Okay, to do this one, okay, I skip a few steps. So in the end, you will have 1.1, 9.67 plus 3.11b. So that's equation number 2. Okay, so the problem is, how could we solve these two equations? Okay, let me put them side by side. So now this is our first equation, and here's our second equation. Okay, let's think, how could we solve this one? Alright, so to solve two equations in two unknown, you need to get rid of one unknown, right? So how could we do this? So you might use the method of elimination. Okay, but how could you use the method of elimination? Alright, so when you try to get a easier parameter unknown to get rid of first, so you see that b is the number in front of b is a lot easier, a lot more easier than the number in front of a. So I'm going to cancel b. Okay, how could we cancel b? You need to get the number in front of b becomes the same. Okay, right, how could we do that? Okay, the thing is, you might consider multiply that 1 with the number 3.11 in front of, which is the number in front of b in the equation 2, and you multiply minus 2.01 to equation number 2. Okay, so the key is these two numbers. Okay, these two numbers. Okay, let's try to do it. Okay, first let me just try to do 1 times 3.11. Okay, so I'm going to times this one with 3.11. Okay, so to do that, that means you have to multiply all the terms by using 3.11, right? Okay, multiply 3.11, multiply 3.11. Okay, after this, you will have, according to my calculation, it becomes okay, so it's very complicated, I have to admit, alright, but it's not unsolvable. Okay, so that becomes our equation number 3, and then don't forget you still need to do something to equation number 2. Okay, so for equation number 2, we need to multiply this one by using minus 2.01. Okay, 2.01 is the number in front of b. We put minus in front of it, just make sure that later on we could just add the two equations and cancel them out. Okay, when you multiply minus 2.1 to equation number 2, that means you have to multiply every term in that equation, by using minus. Okay, so for this one, you will see they becomes minus 2.211 equals minus 19.440 minus 2.2511b. Okay, so sorry, I write this one into better shape. Okay, so at least you should see that now the term b, one is positive 2.62.2511, the other is minus 6.25011. Okay, so that means when we add these two together, they're going to cancel out. Alright, so let's say this one's number 4. Okay, let's try to add them together. Okay, again, please be patient. I'm going to put these two equations together again. Okay. So just okay, let's see if we add these two equations together, what will you get? When we add them together, that becomes 3.5765 plus minus 2.211. Okay, so when you add them together, this one becomes 1.3655, and the other one, when you add this together, becomes minus 6.87621a, and of course these two become 0. So now there's only one unknown left behind, which is a. So you could find a would be 1.3655 divided by the number in front of a. Alright, so this number in the end is very long number. but we could correct that to do 2 decimal place. The 2 decimal place. Alright, now you've got A, but how could we get B? Alright, still remember that, so we go back to use one other equation. So we might use equation number 1. Okay, because now we've got A equals minus 0.1985 something. Alright, so let's just substitute that's A. Okay, of course, some of you might think, could we just use minus 0.20? Possibly not, because that would be rounding off errors. So in the end, we know that the answer should be correct to 2 decimal place. So possibly it would be sensible to use like 4 decimal place instead of all the numbers there. Okay. Oh, sorry, that should be plus. Sorry. Alright. And okay, so it's minus. Oh, sorry, I got something wrong. Sorry. I'm terribly sorry. It's 12:30 in the midnight, so I'm not very good. Alright, so you multiply this number plus 2.0 b. Alright, so I leave the algebra work for you, but in the end you will get that b equals 0.971, which I would say possibly correct to 0.97 would be good enough for us. Alright, so we've got our general form. So A is minus 0.20, x squared, B is plus 0.97x, and there's C. Still remember the C? Long time ago, 1.7. Okay, do we still need to do the tracking? Of course we should, because you can see how complicated is the calculation. And when you are trying to do the tracking, don't use the points here. You want to use the points in the table. Okay, so let's pick any other point. You might want to use how about this 1.55, 2.72 for example, right? Okay, so let's see. So if we use x equals 1.55 as tracking, okay, so this is tracking. So you will have this one square plus this one 1.55 plus 1.7. Okay, let's see how close it is. Minus 0.2 square. Okay, so the answer would be 2.723, which is 2.72. Okay, yeah, agrees with the values in the table, so it seems our general form is correct. Okay, so I've shown you how to find the general form and the vertex form by picking certain points from the table, right? So some of you are going to do the x-intercept form, the theta form. Then you need to pick up 2 x-intercepts and 1 other point. Possibly the y-intercept would be a sensible choice. Okay, and I wish you good luck. Alright, so that's the end of this video. We might have another video on the last 2 parts of the last part of the solve and evaluation and verify. Okay, that's it. Okay, so see you next time.